Hey everyone, Nick Manning here, and this is a continuation of our simple full stack Flutter example app that we've been creating and building over the last few lessons. So in this lesson, we're going to wire up our Flutter app to our backend Dart-based web service API. So what that means is that we're going to learn about HTTP, client-side calls, and also about environment variables and how we can customize our Flutter apps and have different builds of Flutter apps based on different environment variables as well. We're going to be also coding a bit of the UI, so a simple UI, and we're going to be working with state and just a little refresher there as well. So that way, by the end of the lesson, we're going to have a fully working end-to-end full stack Flutter example, and I think it's going to be a great basis for everyone to start expanding and creating actual real apps. So with that, let's get started. Okay, so let's code our UI first really quickly. The UI is going to have two buttons. It's going to be a fetch button and a reset button. The fetch is going to make a web service call. Reset is going to reset what we see on our screen. What are we going to see on our screen? We're going to have a label, and that label is going to show just the raw contents of our web service call, like response. So let's create, since we're using a stateful widget, we're going to create a variable here called message, which is going to hold a web service response here. I have other courses on, stateful widgets, so look at the show notes below, and you can read up on stateful widgets if you're not as familiar. I'm going to quickly code the UI, and the UI is going to be totally centered. So I'm going to use that center convenience widget there. The UI components are going to be laid out from top to bottom. So that's why I'm using a column widget. Let me have some spacing here. So also in the show notes, I'll cite the free lesson I have on layout, Flutter layout. So I don't have to describe what I'm doing here with the layout. So I'm going to have some children here. One is going to be a row. That row is going to contain the two buttons that I have. The buttons are going to be laid out left to right. That's why. So space evenly, and then there's going to be children. And the first button is going to be a raised button. And the raised button is going to have a child with a text widget here, label called fetch data. I'm going to have a bit of color to the button. So blue, text color, white. I'm not using any like Flutter themes or anything right now. I'm just kind of like coding this up for a very simple example. And I haven't written this method yet, but I'm going to have the onPressed handler, a function name called handle fetch tap. So remember, I'm passing the name of the function I want to write, not the actual function. Like I'm not actually invoking the function here. I'm actually just passing the name. So don't write those parentheses here because that's a lot is going to go wrong if you do that. So let me implement, let me just create the function so that there's no errors on the screen. And let me just, while I'm at it, create the other function, which is going to be called handle reset tap. That's the kind of reset button that it's going to reset the screen. It's going to clear what's out on the screen right there. So I have my child there. I'm going to have another raised button, and that's going to have my handle reset tap. So I'm going to have a child with text reset, and then on pressed, it's going to say handle reset tap. And let's save that. And then let's see, raised button. I have that. I need a comma there. That would help. Cool. Now I have on the right side of the screen, you see fetch data and reset. Pretty cool, right? It's not going to do anything yet. So let's code that up. So what it's going to do is I'm going to simulate a web service call. So I'm going to set my message using set state. And again, if you're not as familiar with set state, don't worry about that. You can look at other lessons that I have on state, like working with state and all that. So let's just say test just to make sure it works, for illustration. And I'm going to say set state. and then just reset it. I'm going to set it back to absolutely nothing. And let's see if that works. Message test. I'm setting my message. Oh, duh. I have to create a label to show the data. So let me go and do that last part. I'm going to have another row, and it's going to be main axis alignment, space evenly, and it's going to have some children, and it's just going to have one child. This child is going to have a label in it, but I'm going to wrap it with a flexible widget because I don't know how much data I'm going to get back from the server. And so I want my label to grow. But I'm also going to set the maximum amount of lines just for example. I don't want it to go nuts here. I'm going to have a basic text style as well, where I set my font size because heck, if it's a lot of data, I don't want it to disrupt what's on the screen. So cool. I have my little label here called test. So I hit reset, resets it. I hit fetch data, it shows the label. Pretty cool. Okay, let's do the next part, which is making web service calls. To do that, we're going to use a package because it doesn't, making web service calls, the code that you need for that doesn't come with Flutter automatically. So we're going to use the special pub Dart package called HTTP. Now, I will go in my pubspec YAML file, and under the dependencies section, dependencies lists all the packages I'm using. So I'm using the Flutter package, and I want to now add the HTTP package. But what version do I use? I don't know what to put in here for versions. So what I'm going to do is going to go to pub.dev, search for HTTP, click this tab here called installing, and it's just going to tell me what I need to include here in dependencies. I'm going to copy this actual version because the latest version is 0.12.2. And you're probably asking what this caret means. This caret means that if there's a new, this is how versioning works, right? This is a major version, the 0. The major version is 0, the minor version is 12. And the patch version is 2. So if there's a little tiny tweak, little patch, it's going to increment here. 2 is going to go to 3. If it's a minor version, it's going to go from 12 to 13, for example. And if it's a major version, it's going to be version 1, for example. This caret means that as long as I'm using this version here, and if they release a new minor version or a new patch version, let's say they release 0.13, right? When I run pub get and I get my latest package, it's just going to use that version. It's not going to use 12, it's going to use 13. So that caret is saying, hey, it's okay, use everything from minor version 12 and up, right? So that's just a little cryptic, but it's probably going to bug you if you're like, well, wait, it's probably going to bug you like, what the heck is that caret, right? So anyway, that's a bit about how that versioning works. It's the same in JavaScript as well, by the way. With npm. So let's continue here. I saved the file, right? In most IDEs, when you save the pubspec YAML file, it's going to download the latest package for you automatically. If you want to do that manually, you can just run flutter pub get, or if you're just using pub, just pub get. But usually it's baked into the UI. And now that I've imported it, I have no errors. I can say import package : http/http.dart. And that should work. Now let's see. Why is there an error? So if there's an error, in Visual Studio Code, I'm going to see the console here. So let's say problems. It says it doesn't know what HTTP is. Output, nothing. This is a common problem here. It just doesn't recognize it. So what I'm going to do is I know that I have it. So I'm going to exit. And again, this has happened before. And I'm just going to open up my IDE again. Pretty simple. Nothing. And it'll probably recognize it. So there you go. And it does recognize it. So just a little piece of advice there on what to do if it doesn't recognize that. So let's use our HTTP package now. before we're going to use it, we're going to plan out how we're going to call this HTTP function, right? So we're going to say some var some data, and then we're going to say we're going to have a special method called fetch, and we're going to code it here in the UI. Usually, you do not want to code and implement the web service call directly in the stateful widget that you have. You want to separate code that you want to separate concerns. You want to separate the code that works with web services and makes web service calls with the code that actually renders stuff on the screen. But we're not going to do that right now because this is just a simple example. We will go into other more complex examples later, and then we're going to properly separate our code. So, hey, let's say it's going to return, and then we're going to assign some data to message, right? And that's going to work. Let's go back to our app. I have to rerun the app, for example, because I stopped it. I'm going to hide that. And now let's get started on actually implementing this, right? So with HTTP calls, an error can occur, and we want to make sure the app doesn't crash if some like crazy error occurs. So I'm going to wrap this in a try catch statement, and that way I can handle the error properly. I can print the error because that's just helpful for debugging purposes, but then I can also return the error. So to return an error, this is a special error object in Dart, and I won't cover more Dart language concepts right now, but I could just say error to string, and it's just going to give you a stringified version of the error. Nothing exotic there. But here in the try, I actually can make my web service call. So my web service call is going to have a special URL, and it's going to have a special IP address, and it's going to be, this is the endpoint /example. And here I'm going to return null because this line will never execute, but I think it'll complain if maybe it won't complain if I don't cite that. Try here is going to make the web service call. Now, before I can make the web service call, first I'm going to have to do two things. One, I'm going to have to run my web service, web server. And two, I'm going to have to explain to you what the heck I'm typing here, which is 10.0.3.2. So let me explain that. Let me first make sure I have my web server running. So if I go, this is my code, right? So this is the example code that's public, right? I'm going to open my server. So there's two directories here. I list out. So the way the code's structured is I list out all the steps of this course, like this mini little course I have. So each video I have 01, 02, 03 for every step of the way. So right now I am on this second step, and I'm going to open my server. There's an app directory and a server directory. I'm going to say code server. Code stands for Visual Studio Code, and that's just a shortcut CLI command that opens my IDE, and I can cite what directory I want to open. So if I say code server, it's going to open a new Visual Studio Code window, and it's going to show the server project that I have. Now, read the README carefully. It gives you instructions on how to set this up. We did this in the last lesson. So with that, I don't have to install anything because I have everything installed already. And I'm just going to run my server. I'm going to hit F5 in Visual Studio Code. That's how you run something. Alternatively, I can type the special command to run my server that we also covered in the last lesson, which is aqueduct space serve. Aqueduct space serve, which I just did by just using the shortcut F5, is going to run the server on a certain port. We did talk about ports previously. So that's going to run on port 8888, right? But here's the thing. I can access this web service on my browser. I could type localhost 8888 and then example. And /example is our web service endpoint. And that's going to show the actual data it's going to return. It's going to return key : value. It's just some JSON data. That's what it's going to return. But I can't access this URL localhost from my simulator here, my emulator here on the right. And that's the app that's accessing it. Because the emulator doesn't know about localhost. It only knows about its own localhost. It's its own operating system. This is the Android operating system. It doesn't know about my host's machine's API, like its URL. So with that said, I have to use a special IP to access the, here I'm using Linux. I have to access that the IP address of my host machine from my emulator. And the way that's done in with the emulator that I'm using is I'm going to, let's see, let me open the other window here. Hold on, let me get this back. App, here we go. I'm using the Genymotion emulator. Genymotion, here's the word I'm highlighting at the bottom, Genymotion. It's free. I really recommend it because it's not as resource intensive and it's great for people who are not using a Mac. There's a special IP address that it gives you, 10.0.3.2. That lets me access my URL on my host machine. So let me open a web view here, and I'm going to type http://10.0.3.2 : the port / my endpoint / example. And I hit that, and there's key and value. That shows me that it's working. So I know I can access this via my code. Okay, so how do we get data from this URL? We want to get the actual raw string value from the URL. What we're going to do is make a GET call, and that's a web service terminology for just getting some data at a given URL. That GET call is going to return a response, but it's going to return like a future of type response. And futures, async, await, all these terms you can read about in the show notes. I have another kind of information on async, await, futures, but basically it's what we mean. What we mean by that is that it's await like lets you call an asynchronous function and not continue the code until that's done. So the actual call we're going to call from using the HTTP package is get. So get is a special HTTP kind of way to fetch things via web service URL. And if we hover over the get function here, it's going to return a future of type response. So that means that it is asynchronous, and the response is going to come back sometime in the future. It could be 10 milliseconds from now. It could be a few seconds from now. We don't know when it's going to be returned. But what await does is that the code will await for this to complete. We're going to wait for the actual response to be returned to us, and then we're going to continue execution. So that's why we have to use this await kind of like terminology here. Because we're using await, the function that wraps this code, this fetch function, we have to label as async. We have to tell Dart like, hey, this is an asynchronous function. So that's a requirement to await. If we don't have that, it's going to error out. So we're going to say, hey, this function is asynchronous because it's doing something asynchronous that may happen, again, 10 milliseconds from now or a few seconds from now. Who knows? So we have this response here. Now, the way the HTTP package works is that the response has a field called body. And body is just a string, and it lets us kind of get that raw data as a string. In more advanced examples that we're going to have later, we're going to learn how to, we're going to actually do something with this string. So we can instantiate it into an instance of a class or something else. But for now, we're just going to show this string on the screen here. Now, I can't just return response body. Why can't I do that? Because of the fact that any function marked asynchronous can't just return some data. It has to return a future of type whatever data you want. That's just how async and await works, right? Because it's asynchronous, we don't know when that data is going to return, right? So I don't know when the get call is going to finish, and consequently, I don't know when this fetch call is going to finish. It's undefined. So we have to kind of like tag this return type with a future of type string. So if you want more information about async array, just look at the show notes, and there's more information on how to learn more about that there. But this is what we're going to do. That's all we're going to do. We're just going to return the response body. That's it. So now that we have our fetch call, there's a problem here. Fetch, we have to also use await for, because fetch is an asynchronous function. So we also have to label this handle fetch tap as asynchronous, right? So we have to await the result of our fetch call. And after that call is finished, we get some data, and then we assign it to message. So the URL is correct. This all should work. So let's try it out. I'm going to save it. I'm going to run my app. And it's going to take a few seconds to run here. It's going to compile it because we're doing that for the first time. I had the app stopped at the moment. And just while it's doing that, I just want to make a note that, in any kind of stateless widget, the code that actually contains what's rendered on the screen, all the Flutter widgets and all that, you don't want to kind of mix with actual kind of backend type code where I'm calling a backend service. We want to separate the code very cleanly. So again, as a reminder, this is just for an example purposes. We're not usually going to have a call to a web service here in our stateful widget. Okay, so now that the app is loaded, I'm going to hit fetch data. And cool, I get the data back, key value, in the label down here. So we know it works. We can reset it and call it again, right? So that's pretty cool. We have that complete. So the next thing I want to talk about is how we configure our app with different builds. Here's the thing. When we're developing locally, we're gonna have this URL point to a local server, and that's our IP address. If we have a backend web service, we usually have that web service hosted at a host name somewhere on the internet, right? We're gonna cover deploying this web service in another video, but what we do is we usually have two servers that the backend code is going to live on. One is a kind of sandbox server where we can do whatever we want. We can break it. We can make all the changes we want, test it out, and do whatever we want with that. So that's usually called a kind of staging server or development server. There's another server that we deploy to. That's the actual live server that real users use. That's the one that when you submit your app to the App Store, it's going to actually wire up to that production server. That's called production. That's your live server. So because of the fact that we're deploying our backend code to multiple servers, when we use different versions of the app, though each version of the app is going to point to a different server. So for example, locally, when I develop my code, I'm going to point to my local server here, this IP address you see here. When I send the app out to my friends to test, say, hey, can you test the app out? I haven't submitted it to the App Store yet, or I've already submitted to the App Store and I have a new version. That test app is going to maybe point to your staging server, your sandbox server, right? Because maybe that server might have new features that you want to try out, and you don't know if it's tested well enough yet. You just want to play around with things, right? You don't want it to point to your actual production live server. And then you're going to have another version of the app that you build build and you release that is going to be actually submitted to the App Store. So that version that's going to be submitted to the App Store is going to have a different value in it. And so it's not going to have this IP address. It's going to have the address of your live server. So these are what we call environments, right? There's a staging environment, production environment. You can have another, like a development environment. And so we don't want to have to change this string every time we have a different build of the app, right? We want to have a flexible way to configure this. So I'm going to have different ways that this Flutter app builds. One first way is I can just build this to point locally, and I just run it, and I point to my local IP address here. Another way I can build it is for just staging mode, where just as a test mode where I send it out to my friends, as I just said. So we're going to be covering how to kind of create multiple different types of builds for Flutter apps later in another video. But we have to have an easy way to configure this without having to change the code constantly. And the way we do that is with an environment variable. Environment variables are basically variables that the code has access to, and they can specify different environments. So when we build our Flutter app, we can have an environment of staging or an environment of production. And when we build that app, we say, hey, I'm building this Flutter app for staging. So it's going to use the staging environment variable. Or if we build it with production, it's going to use the production environment variable. So this is where we get into the package. The next package I want to kind of explain here is the .env package. So let's install the .env package. It's actually called Flutter _.env. So I'm going to go to the home page here, and I already looked it up in the pubdev site. And remember, note that there's two packages. There's one .env package, but you're going to want to use Flutter _.env. This is the right package to use. And let's just install this quickly. So we have to create an env file. We've done that. It's right here. It's called local.env. And I have API base URI and then whatever hostname I have here. Later, we can create one for staging, production, whatever. But that's what I have for now. The next thing we have to do is go into our pubspec YAML and say assets and cite the env file that we have there. So pubspec YAML, and I have assets here. I already included it here, local.env. I don't need to kind of specify it. I already created it here. So you might want to type this in. We want to actually install the package. So let's look at that example here. In the installing tab on this page, it says what to include as a dependency. So I'm going to copy that, and I'm going to say dependencies flutter _.env, and then the version name. It's going to fetch the package, and then let's go back. Let's see how we can use it. Also, we want to add the env file in our git ignore. I don't want to do that right now, but because it doesn't contain any sensitive data, so usually I can do that. That's fine. I don't know why they think that it should be ignored, because that assumes I have sensitive data in that file, which I don't. Those URL for my web service API is a public URL. Okay, so we want to init this. So in our main.dart, we want to kind of load whatever environment variable file we want to use. So let's include it in our main.dart file. So I'm going to go to main.dart, say import package flutter _.env. And let's see here. It doesn't recognize it because let's stop it. I think I have to restart my IDE because it didn't recognize it for some reason. Okay, now it recognizes it. Cool. That's just a little quirk with my IDE. I don't know why that does that. Cool. Let's just copy and paste the actual code for what we need to include in our main file. So before we actually run the app, we have to load this. So we have to say await.env load and then the name of our file. So our file is local.env. So I'm going to save that. And then in our app here, we can actually use it. So let me copy this import directive here. And then down here, let's look at the example. We can just say .env and then call this special function .env to get the variable we want. So I'm going to use this special Dart syntax that lets me use a variable or make a function call in a string. So that's the $, curly brace, and then ending with a curly brace here. So I'm gonna I'm gonna kind of like call this class here. I'm going to instantiate it, and then I'm going to call a method. Say, hey, I want to get a environment variable name that I have in my local M file. So I'm going to copy this variable name, include it in here, hit the save button, and that should work. I'm going to run my app, and that is it. Let's see, let's wait for it to start. And that, I think after that, our code should be very simple, straightforward. There's nothing else we have to do in terms of environment variables. But one thing I do want to note here is going back to our main.dart. Later, when we build different versions of the Flutter app, we're going to have one for, we're going to build one for like a staging environment where we send out test apps and it points to our test web service API. But then there's other ones we're going to submit to the actual app store, and that's going to point to our production web service API. So technically, there can be different kind of like app.dart files, and we can load different environment variable files with those different app.dart files based on the type of build we want to execute. So I'll show you how to do that later. That's more of an advanced thing, but just note that there can be different like main.dart or app.dart files based on how you want to build. And so that's why for now we're going to hard code this local M file in this string here. Usually we'll have different versions of that and code it differently. There's going to be different values. There's going to be a staging.env, a production.env. So cool, it works. My code works again, and yeah, it looks good. I have the data on my screen. I can reset it, hit fetch data again. It works. Great, so that's .env. So I hope this lesson was beneficial for you. I hope you learned a lot. Again, to summarize, we went over just basic stateful widgets and drawing a simple UI. We wired it up to our web service API using the HTTP package, and we made it kind of flexible and configurable by using the flutter.env package as well. So in other lessons, we're going to learn how to deploy our code, our backend web service API. We'll write some tests for it, and we'll start building this out more end to end. So we have the end-to-end example working locally, but now we just have to cover all the server stuff, like how Docker works, how you build an actual Docker image, how you host it on Google Cloud Run, and all of that. So that will after we're done with that, that will probably complete our end-to-end example where you're going to feel comfortable about building backend web services, deploying them, testing them, and kind of building Flutter apps that wire up to those web service APIs. So thanks for watching, and I'll see you guys next time.